For exercise number 12, we're actually going to be implementing a solution that helps us calculate prime numbers. The reason this is V1 is because the few next exercises are actually going to iterate on the approach towards calculating prime numbers. But this one we're going to do the V1 approach. So the V1 approach uses a vector to figure out what are the prime numbers. And the way that it does it is that it actually takes a number, let's say 13, and then it looks through the vector for all of the prime numbers it's seen so far, and it checks to see if the current number we're looking at divides by any one of the prime numbers. This is effectively a form of prime factorization, which you've probably covered in like 5th or 6th grade. So if you find a prime number, then you know that this is divisible. You know the number you're looking at is not divisible. And if you don't find one that divides this number equally, then you know that the number you're looking at is prime. So we start with a vector. The vector really contains 2 in the beginning, one value. And what we're going to do is we're going to try and see if the next number is divisible. So the next number is going to be 3. Is it divisible by 2? It is not divisible. The way we know that is because we went through all the items in the vector and we didn't find any numbers that divide the number 3. So that means that we go ahead and add 3 to the vector. The next number is 4. So then we go ahead and start again from the beginning and we check. Is 4 divisible by 2? Yes, it is. And if it's divisible by one of the numbers in the vector, then we don't add it to the vector. The next number is 5. We repeat the same process. I didn't move the arrow along the way, but it gets to that place. And you can see it gets to the end of the list. Therefore, we know that 5 is a prime number. It's not divisible by any numbers before it. 6, again, we'll go back to the beginning. Is 6 divisible by 2? Yes, it is. Therefore, we know it's not prime, so we go to the next number. The next number is 7. We again would repeat the same process. Is it divisible by 2? Is it divisible by 3? Is it divisible by 5? Not divisible by any of them. We get to the end of the list, and we add 7 to the end of the list. And so now we know that 7 is a prime number because it wasn't divisible by any of the numbers before it. And we keep this algorithm going over and over and over again. How long? Well, until we get to one of 2 cases. Either the size of the vector is of the desired length. What that means is we've figured out the first x primes, i.e. the first 100 primes or 1,000 primes or 250 primes, or until the highest number in the vector is less than or equal to some number that we're looking at, i.e. what are the primes up to 100, or what are the primes up to 200 or 1,000, and so we can do the calculation. Either one of those 2 conditions, depending on what you want to try and calculate, is when you're going to stop this operation. For this exercise, we're going to be calculating all of the prime numbers up to 100, so we're going to go from 1 to 100. We're going to do this operation, and that's how we're going to get to fill the vector. And if we wanted to figure out what are the first 100 ones in the future exercise, effectively, we do the same thing, but just we keep doing it until we get to the size of the vector. This is the quick introduction to this exercise. We're going to now transition to actually solving the problem. Okay, we're going to go ahead and transition now to the implementation from the presentation. The presentation is linked in the comments. If you want to see it as a set of slides, they're linked in the comments. You can see that there. Let's go ahead and transition to the implementation. What we want to start off with is actually creating the method that's going to do the core of the calculation. So let's start with like this. We're going to have a method that's going to return to us a vector of ints, and we're going to call it get primes up to, and this is going to take an integer, and that's going to be our upper bound in terms of the number up to the max that we want to achieve, i.e. if we want to get up to 100 or all of the primes up to 500 or all the primes up to 1,000, whatever it is. So we first need to create a vector in here. We're going to call it the primes vector. And we're going to go ahead and initialize this right away with 2, just like we said in the algorithm. And we're going to go ahead and give the return function here as well. We're going to go ahead and return. So this is our main body. This is one way of running a good method. You have your top, beginning, and your type signature well defined, and you return right away. So this helps it with to execute things. So now we're going to do like this: for int I is equal to 2, I is less than or equal to n plus plus I, and what we're going to do is like this: for int p in primes, and this is what we're going to do. We need a boolean over here. Bool is prime, and we're going to set it to true. And we're going to say like this: if I modulus p is equal to 0. So if we take I and we divide it by one of the things in prime, and we get a 0 remainder, that means that it is divisible. Then what we're going to do is we're going to say is prime false. Now, once we get over here, and this is actually going to be a little bit slow, but that's okay. We're not trying to optimize it just yet. So if anybody's watching here, so there's lots of optimizations you can do, I agree with you, but that's fine. We're going to say if is prime. Now we know that I is a prime number. So what we're going to do, we're going to say primes dot push back I. And that is it. This is essentially the whole method here. We can actually walk through what's going to happen here with 2. So 2 is going to be divisible, so it's going to say it's not prime. It's going to skip it. 3, it's going to do the same thing. It's not divisible. It's going to do that. 4, then you get to 4. It's going to start again from the beginning, and it's going to do is 4 divisible by 2. It is, so it's not, so prime is false, and then it's not going to add at 5. Then it's going to add that value. Great. So this is how the method works. And now we can go ahead and actually write the small driver for us. So let's go ahead and do like this. Standard vector int primes to 100. And we're going to go ahead and call it get primes up to 100. And now what we're going to do is we're going to say standard cout primes to 100. And we'll go ahead and just loop through it. So for int p in primes to 100, standard cout p, and this is effectively it. Now that we have the whole logic factored into a method, it makes the whole process of actually validating that it works easier. And in the future exercise, when we want to refactor it, will give us an opportunity to do that. So let's go ahead and just run it. So we're going to hit the run. Let's go ahead and compile it. And there it is. And so here are the numbers. We can see it's 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43. And it gives us all the way up. So I've spent enough time doing mathematics. All of these numbers are familiar to me. And we can do another method line just right here like this, standard cout. There are a total of primes to 100, that's size, prime numbers between 1 and 100. We can do this. And so just to get a sense for this, let's go ahead, same thing, run, and there are 25 prime numbers between 1 and 100. And that looks about right. Okay, this is good enough. We can go ahead and ship it. And this finishes up the exercise for calculating prime numbers.